Spain's challenger in metrology, Wooptix. This Spanish measurement startup has just installed its equipment at a prestigious French research institute for the very first time. This isn't news about a mass production factory, but personally, I think this is a company worth keeping an eye on. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. We're going to start with a woodworking analogy about joining thin wooden boards into one perfectly flat tabletop. So sit back and enjoy.
Let me start today with a woodworking analogy. Imagine taking several thin wooden boards and gluing them side by side to create one wide, flat tabletop, maybe for a dining table or a cutting board. Each thin plank has to line up perfectly flush with the others. When it all comes together just right, that's the mark of a truly skilled craftsman.
The most critical thing in this process is flatness. What happens if each individual plank is just slightly warped? Gaps form at the seams where they meet. Or worse, the entire tabletop slowly begins to bow over time, creating waves across the surface, and the piece becomes completely unusable.
The tricky part is this. The thinner the boards and the more boards you stack, the more that tiny warp starts to matter. A warp so small you'd never notice in a single plank can accumulate across multiple layers into a defect you simply can't ignore. In fact, it's entirely possible that everything looks fine right up until you add that very last plank, and suddenly the whole thing falls apart. So how does a craftsman check for flatness? The old-fashioned way is to pick up a few boards, hold them up to the light, and run a straight edge along them. It works, but it's slow. And more importantly, out of all the boards you have, you're only ever checking a small sample, not every single one. Now imagine you had a tool like this, something that could scan the entire surface of every board in an instant, mapping every high point and low point like a topographic chart. And instead of spot checking just a few boards, it checks every single one as they come down the line. Believe it or not, this is exactly what's happening right now in the world of semiconductors. Let me summarize the woodworking stance. The boards are wafers. Gluing them together is what happens in hybrid bonding, HBM stacks, and 3D NAND. And the warp in each board? That's what we call bow and warpage in the wafer world. As the semiconductor industry moves into an era of stacking chips in 3 dimensions, managing this warpage has suddenly become critically important. And honestly, my current view on Wooptix's Phemet is almost exactly the same as this woodworking story. Phemet captures a full wafer measurement in a single shot, acquiring approximately 16 million data points at once with sub-nanometer height resolution. The use cases become clear. Catch warped wafers before bonding, detect process drift early, and pull out the problem units before they ruin the stack. These are exactly the problems it was built to solve.
The installation site is CEA-Leti in France. The name might make you think of nuclear research, and you'd be partly right. The parent organization, CEA, is the French Alternative Energies and Atomic Energy Commission. But CEA-Leti, founded back in 1967, is one of the world's leading applied research institutes, specializing in semiconductors and advanced packaging technology. Of course, there are powerful incumbents in this space. For front-end process control, KLA leads the world. In advanced packaging, Onto Innovation is a comprehensive player, covering metrology and inspection across RDL, TSV, hybrid bonding, and panel-level packaging, a broad and well-established portfolio. So, I'm not saying Wooptix is about to replace KLA or Onto anytime soon. The semiconductor equipment world doesn't run on performance specs alone. What actually gets evaluated is a much longer checklist. Production track record, customer qualification, service infrastructure, analysis software, and proven yield improvement know-how. All of that gets scrutinized together.
A word of caution on the language used here. The announcement referred to a production tool, but that means the first commercially shipped unit of the product, not a deployment on a volume production line.
The installation site is a research institute, not a mass manufacturing fab. And CEA-Leti itself used careful wording. It is evaluating the first fully automated 300mm Phemet. That's deliberately measured language, and it matters.
So does Wooptix have a real shot? I do see a path, but it's a concentrated attack strategy. Rather than trying to become a broad-based player like KLA or Onto, Wooptix could carve out a position by going deep on one specific capability: high-speed, full-wafer measurement of warpage and nanotopography, the exact measurement that becomes mission-critical in the hybrid bonding era.
In the semiconductor equipment world, there are plenty of companies that never replaced a major player wholesale, but became the go-to for one specific step. This process? This is the company for that. That kind of focused positioning is a very real form of winning. If Phemet can claim that corner of the market, that would absolutely count as a successful outcome. What's also interesting is who's backing Wooptix financially. Beyond Spanish government funds, their investors include Samsung Venture Investment, Intel Capital, and TEL Venture Capital. Intel has been involved since 2016. Samsung joined in a more recent funding round. When major semiconductor players commit capital this early in a startup's life, it signals something far more deliberate than a typical university spinout. Spain isn't a semiconductor powerhouse, at least not yet. There are no giant fabs, no equipment giants like ASML, but in recent years, a wave of sharp startups has been emerging in areas like RISC-V, photonics, chip design, and metrology. Wooptix is squarely one of those challengers, and it's part of a broader pattern worth noticing. Let's be clear-eyed about what this all means. There's no need to overstate the significance of this news. This is still the evaluation stage at a research institute, not a deployment on a production line. One tool placed at a research center does not mean a row of them installed across volume fabs. In the equipment business, the road from here to there is genuinely very long. One of Wooptix's investors, TEL Venture Capital, is the investment arm of Tokyo Electron. TEL is a major manufacturer of process equipment used in HBM and 3D nano production. So why would they bet on a metrology startup? The logic is straightforward. The more precise the stacking requirements in their own process equipment, the more critical warpage measurement becomes. If that's the thesis behind TEL's investment, then Japanese equipment companies may not be as disconnected from this trend as it might appear. Let me wrap up. Wooptix is currently in the evaluation phase at a research institute. Mass production adoption is not around the corner. That said, as HBM and hybrid bonding become mainstream, managing warpage and surface topography will only grow in importance. A Spanish startup has placed its first unit at a top European research institute with backing from major industry names. No need to overreact, but no reason to dismiss it either. Personally, I'll be watching closely to see whether Phemet makes inroads into volume fabs from here. That's all for today. I'll keep bringing you semiconductor news and analysis. So if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.